last Thursday of the month here in this office with a different speaker each time. And this is the Vantage Office. We are a cloud cost optimization and visibility company. We raised a series of new audio systems, so still kind of learning the tricks. But there's a series of last year. We've got hundreds of customers, tens of thousands of users. So we want to welcome you to our office. And I am here to introduce Elena Felder, who is a software engineer at MotherDuck. She's the lead on the ecosystems team and is one of the most tenured engineers at MotherDuck. At Vantage, we use MotherDuck for a few different things. We also use it as part of our product, so definitely encourage you to check them out. And with that, I will hand it over to Elena.
Hello, I'm the person who had to give up pizza for. Hi, and welcome to the Infra Meetup. I am not quite your host, but I am your presenter for the day. And we are going to be discussing S3 in something with disgusting level of detail. Naturally, there will also be an advertisement of my favorite job in the world. It involves ducks, but it will totally be worth it because of the things I related. So today's topic is querying S3 data, something most people have to do on occasion. The subtitle there is keep your friends close, but keep your AWS posts closer. Keep your S3 data closer. So why am I doing this? I get blackmailed. My name is Elena Felder, and I am very active on GitHub and very not active on any other social media like this. But that is where you can find me. I lead the integration team at MotherDuck, which means that everything that I touch is my job, and so it's understanding why everything the light doesn't touch is broken. Before I embarked on my duck shape adventure, I mostly was a Java developer, mostly on the backend, although I did switch to the front end every few years just to make sure I was keeping current with whatever breakneck speed and crazy architectural patterns the front end folks came up with this time. Mostly so I could troubleshoot end to end. I was thinking about databases, but not quite working on databases. And MotherDuck, I was thinking you're thinking about databases, but not quite working on them. So that fits the pattern quite well. And my personal hobby is looking at the data and trying to tell a story. Because there is a reason why you keep all of gigabytes upon terabytes upon whatever it is of data. It's because you want to learn something from it. And if you ask the data nicely, it will generally tell you something interesting. And if it doesn't, you don't have the right data. Before MotherDuck, I worked at Google, at Federal Reserve Bank of New York, at another startup, at Federal Reserve Bank of New York again. And the first time, before I put my running, I got to hold a gold bar, and the way it looked like was this. Because gold is a lot denser than you think. All right, and yes, I have approximate knowledge of many things, and on the ecosystem team, the breadth of my knowledge has grown immensely, and the depth of my knowledge, I am afraid, is approaching zero at this point. So, the prologue. I wanted to know how fast we could get data between different Amazon properties. And it turns out it's pretty damn fast. 100 gigabits per second is a lot. And then I did my home internet speed test, and I have really good home internet, thinking you are from not having an internet monopoly, but math is hard, but the AWS to the AWS data speed looks a lot bigger to me, a lot faster. So we're just going to keep that in mind for the rest of this. Please welcome our protagonist, the duck that ran the New York City Marathon. Not actually. This is just a cute picture of a duck. A duck didn't run in the New York City Marathon. I don't know why, but it is the cutest thing ever. Our protagonist is actually the infamous yellow taxi cab data set from New York City. I do not know why it is infamous, but I do know that everybody uses it for different data presentations, and I also do know that every time I heard the word New York City taxi data set, there was the word infamous in front of it. So I'm just, monkey see, monkey doing the term. It's about, I only got the yellow, cat data set, even though I live in Brooklyn, so I should probably not be discriminating against the green cat, but I wanted about this side of data. So I'm looking at this 27 gigabytes of Parquet files to compress, uncompressed CSV, because I actually accidentally tried to download the uncompressed CSVs, and that's intimidating. So 27 gigabytes, is this big data? It is not big data. Let's face it, but it's big data, respectable size data. And you can check out for yourself. New York City hosts the data in at AWS and the following S3 file. So there is one more thing that we are going to need, a problem. And my problem is trivial. I want to take those 27 gigabytes, and all I care about, just for the data structure exploration purposes, I want 100 rows. Is that too much to ask for? We will find out. My first attempt, because I'm a backend engineer with an AWS CLI installed, I am going to download this data using the AWS S3 CLI. It took 12.5 minutes. And I'm not even going to mention how long it took me to figure out how to correctly format the AWS S3 CPU command. It is an embarrassing amount of time, because apparently if you switch into the next mode, nothing good happens. So yeah, 12.5 minutes, my home internet is pretty good internet, it's variable, right? It's a lot of gigabytes of data. Just to prove my honesty here, I checked the file size, and he has 27 gigabytes of data. As AWS S3 buckets with their perfect internet speeds to my 12.5 minutes, say it is sounding mad. I got the files. It's a lot of files. What the heck am I supposed to do with all of this? I certainly cannot open it in text editor. It's compressed Parquet, very size efficient, very unreadable. I do not speak Parquet, nor anything else really except English and Russian. And as it happens, I really don't want to learn Python. It keeps kicking my butt every time. So for the purpose of this, not today's name. So there are other tools other than writing your own custom Python that can read Parquet files. I reached for my favorite multi-tool that I've been using to parse everything, JSON files, Excel files, the counter to my fridge, DuckDB. DuckDB is awesome because and I don't work for them, and that's awesome. It runs in process in pretty much anything you can imagine. But we'll talk more about what it is and why it's awesome a little bit later. Like now. So what is DuckDB? It's an analytical engine. That sounds like marketing. It is an analytical engine. It's a literal database engine to figure out how to parse a query and how to optimize it and how to execute it and how to return the data back to you. It is also a storage format which is becoming increasingly stable as the year for their 1.0 release. I am shocked how many production places DuckDB has made its way into, given that it has been pre-GA, and they kept changing the storage format drastically, improving it every time. It's actually much better than Parquet. It's like 20% better than Parquet on this data set. I checked the database sizes. How many of you have heard about DuckDB even? That's, good. It's more than half of the room, probably close to 2/3 of the room. How many of you have used DuckDB? It's fewer people, but it's still a sizable part of the room. I find once it's like chips or something, or as our CFO says, orgies, you can't have just one. Once you start using it, you put it everywhere. So the storage format is great, and actually the last release that they did, it was backwards compatible, which is amazing to see. DuckDB also has ETL KPIs in every language you can think of. It's actually a native binary. It's written in C++, it's compiled natively, that's why it's so fast, and that's why it's so awesome. But it also has, it has a GDBC driver, it has a non-GDBC driver, it has a Python library, it has a Julia library. I didn't know what Julia was until I started this job, but now I know it exists and that you the CAK because I broke it. And very importantly for us as a company, DuckDB comes with an extension API, which enables all of our shenanigans. It also enables a thriving ecosystem of extensions. The most popular are JSON and HTTPS, which is what enables us to read Parquet files to get files off the internet, but there's also ICU for complicated data management and a limited number, a finite number of extensions managed by DuckDB, but a limited number of extensions you can just develop by yourself. Alright, what is MotherDuck? And why do you need more ducks? We already have one duck, isn't that enough? MotherDuck took DuckDB and put it in the cloud. DuckDB has always been able to run in the browser. It has a great WASM variant, but we connect the client DuckDB to a server DuckDB. You can think of it as your personal data warehouse, your team's personal data warehouse. It's a great data exploration front end, which has been getting more and more cool features. I don't like autocomplete. I don't like machine learning assistants that change what I wrote. But our SQL fixer, our functionality is something I actually use because I make typos, a lot of them, and it just fixes my typos and table names for me. And also, my job is an endless source of backgrounds. I appreciate that. And there is my actual job, the partner ecosystem, which the original slogan was everywhere you can duck, you can MotherDuck, and it's absolutely true. DuckDB has all those amazing services in every language imaginable, and a lot of different data analysis, data ETL, data ship your data from point A to point B, do something useful with data. A lot of those tools integrate with DuckDB because it's convenient. They can do some local pre-analysis, then they can ship just the results to the server or the other way around, and it's great. So here you can see the Java, the JDBC driver usage example, the CLI, command line on any architecture, and an example of the most popular DuckDB integration, which is Python. Unsurprising because DuckDB is very big on the data analytics community. So this is my ecosystem. The stuff in yellow is DuckDB, the stuff in orange is MotherDuck. Of course, going to MotherDuck opens up the portal, which magically brings into all kinds of other cool functionality. Here's Python, and then you have stuff built on Python, the SQL, which is the main Python ORM. On top of the ORM, you can have BI tools, data visualization tools. You can have data transformation tools, anything you can imagine that has to do with data. DuckDB either makes it easier or there is an integration in the partner ecosystem that makes it just work for you. So, why are DuckDB and MotherDuck different and what are they for? DuckDB aims to be the best in process single user analytical database. It already delivers it and it's not in 1.0 yet. They're just working towards 1.0 right now. It has an exclusive anti-goal of being a multi-user database. So once you outgrow your single person use cases, you need more or you need something different. And MotherDuck's goal is to be DuckDB for teams, to be a great data warehouse that's easy to use, easy to access, easy to share your data in. So I find DuckDB to be an incredibly useful multi-tool for my personal life. I've downloaded my Twitter archive, I have imported it into DuckDB to query it, it's great. But to get with MotherDuck, now it opens up a whole lot more possibilities about sharing the data and analyzing the data. All right, so that was the marketing spiel and the I love my job spiel. Let's get back to our actual problem, the S3 files. So I downloaded those Parquet files, it was a lot of gigabytes, 27 I think. It took 12.5 minutes. So now I'm going to look at them and get my 100 rows with DuckDB. So I'm turning on the timer just to make sure, we'll find out how long it took, because I am not doing a live demo today. It is a rainy day in New York, nobody has the energy to do a live demo on a rainy day in New York. And here we're going to use DuckDB's extension to read Parquet from my data files, from all the CEO Parquet files. And we are going to ignore the fact that New York City has changed the reporting format, as the data source providers always do, so we have to provide the option to prevent the parser from complaining that, look, this file exists in those in 2014 files, but not in 2015 files, what's happening? So this took a fifth of a second, which is amazing, right? It is amazing. I love it when things return that fast. Except, remember that 12.5 minutes download I had to do first. I got a cup of tea, I already forgot what I was doing by the time I got back to this, and if I didn't have my to-do note, or get 100 rows from those market files, I would not have remembered how to get back into this. Anything that breaks your development flow is bad. All right, let's see if we can do any better. Yes, Python, I know you can. It will probably also take you 12.5 minutes to download those files from S3. Thank you. All right, so we're already using DuckDB. It's possible that there is no need to pre-download the file, seeing that Parquet does come with metadata that should in principle tell you how to get 100 rows without downloading the whole gigabytes of data. Let's try it. So now we are starting DuckDB against the local database. For no reason whatsoever, because we know that we're going to be using this local database. We might as well have started DuckDB with no parameters for in memory experience. Turning on the timer again just to see how long it takes, and running a similar read Parquet statement, except this time going directly to S3. So that takes 307 seconds, which math is hard, but it's about 5 minutes. So let's go to 14 minutes. We have just proven that when DuckDB was reading Parquet files off of S3 directly, it did not have to download all of the files, because as we have already established, that would have taken 12.5 minutes. That's pretty good. Honestly, I would have settled for that if I didn't work for a Dutch company named MotherDuck. I always want to see how we compare. And so we're going to do the same thing. Remember, anywhere you can duck, you can MotherDuck. So here we're MotherDucking. We're starting the same DuckDB command, except instead of passing nothing for an in-memory database, we're passing a local file for a local database that sits on the file system. We're saying empty colon because I'm too lazy to type in MotherDuck colon, which you could also do if you're being fancy. Again, turning on the timer, again, selecting the Parquet. This statement is identical to the one that we ran in plain DuckDB. And this time it takes 43 seconds instead of 5 minutes. And that's a great deal better than the original 12.5 minutes, but we're not even comparing to this. All right, so 43 seconds compared to 5 minutes is a huge improvement. The question is, other than my love of ducks, why is it so much better? And the answer is a combination of two factors. One is magic. MotherDucking hybrid execution, otherwise known as duck magic. I might have just invented that. And that is data locality. It's a lot of gigabytes of data, and while my home internet is very good, it's still, is subject to the laws of physics. And yes, light travels very fast, but there are a lot of people in my neighborhood who would like to take advantage of light traveling very fast on Verizon files. So anything you can do to query your data closer to where it's actually located is going to give you a better experience. And very relevant to our friends at Vantage interests, it's also usually cheaper. So this is the reason. Remember the comparison between AWS maximum speed, which we're not there. I was definitely not getting 100 gigabits per second with those results. It's still 47 seconds. It was not 1,000 times faster. But still, it's a great improvement over my home internet. So what is hybrid execution other than dark magic? If you would like a formal explanation, we published a paper. It is official and everything. This is the link at which you can get the paper. I will just stop here to meditate on ducks while you take a picture of them. All right. If you would like a less formal explanation. Hi, the execution, everyone. I will show myself out eventually. Our machine learning team lead actually made the prompt that resulted in this, and I love this so much. All right, how does this actually work? Something that's lower level than marketing speak and higher level than you having to go home and read the whole paper. The paper that is really readable. So the first time we ran this, it was purely local execution. MotherDuck is not in the picture at all. You only have your DuckDB. Your DuckDB reads the engine scroll of your SQL. It then parses the query. It looks at the local catalog to figure out which columns exist, which tables exist, how to bind the data. It then loads up its optimizer to figure out how to best execute the query. And it's doing a pretty good job because, yes, it might not have been as simple as doing a head command or on the 100 lines of a text file uncompressed. But remember, this is very compressed, very efficient data. It is going to take a little more work than that. So yeah, it optimizes it creates a query plan for how it's going to execute the query. It goes to the local data. That was the very first example where I had it on my local file system. In the second example where we went to a tree, your local data is actually all the way on the thing. Green bucket that's very far from your home internet. Also, your significant other is probably commenting the latest Google show or something. All right, so that is what we do all the time from the locals, going all over there. So obviously, the very first test we did where the files were locally after 12.5 minutes of hard work of me drinking a cup of tea while my computer was downloading it. Yeah, sure, that took a tick of a second. It's right here, the data's right here, local. And when you had to look at the parquet headers on a whole bunch of parquet files all the way out in like Virginia or wherever US East 1 is located, that was longer. All right, so that's local execution. What happens when you do remote execution on MotherDuck servers? Well, the diagram certainly looks more complicated because now you have a DuckDB here and you have a DuckDB there. You read the agent's code, you SQL once again, and you do the same parse and bind step. You still consult the local catalog to see what tables, what columns are relevant here. You still go to your optimizer, but now your optimizer says, wait a minute, I am a MotherDuck extension aware, and I'm going to make my plan for how I am going to spend my time reading this data from all the way over there. And I'm going to ship this plan over to MotherDuck servers, where MotherDuck server can change the plan and make a better plan. So in this case, the MotherDuck is also running a parse and bind, except not really, because it was already parsed and bound. It is going to optimize and execute the query. So the optimize step is going to be like, well, the data is right there. We're not running this locally, we're running it on the server with this very, very big data pipe. Data is a series of pipes. This is a damn big one between different AWS properties, probably in the same region. And then once it reads all the metadata, that took 5 minutes load from local, but it only takes 47 seconds from the server. And I was like, well, I got 100 rows. That's it. I don't need to do anything. And then it fetches the 100 rows back, which is why my local internet speed is relevant. So right after I did this, I went on my mobile hotspot for reasons, and I tried to repeat the same test. My local DuckDB attempt to read the 100 rows of Parquet files, never completed, and my phone started screaming at me about having used 2 GB of data, which I see point, okay. The MotherDuck timing remained the same because all it needs to do is get 100 rows of data back. It's a very small data set. Even my phone couldn't handle that. So this is something we have not seen, but if I wanted to join data, what would have happened is the actual magic of headless execution, which is the local planner and the remote planner would get together and they would gang up on this data and they would figure out how to most efficiently get it to you. So if I'm looking at some local data and I'm looking at some S3 data, the server is going to handle any filtering on the remote data, and my local package is going to handle any filtering on my local data. And then it's going to look at the approximate row count for the two things, and then it's going to be like, well, my local data is small and my remote data is large. I'm shipping the local data to remote for the final result computation. And if it does, it's going to do the opposite. And there is really no limit to how smart you can make optimization like this, because you can figure out all kinds of historical data runs. There's just a ton of interesting problems for how to optimize this, but there's also ability to do so for once. All right, now we're going to check the honesty by looking at explain plans. So obviously the MotherDuck explain plan is much more complicated. There are no steps. If we look at the DuckDB plan, all it says is I am reading the Parquet file and I'm applying a limit. And by the way, DuckDB by itself, the extension have predicate push down, which means that the limit, it's not going to need to read the whole Parquet file to limit the rows. It's going to still have to get some major metadata out, but it's not going to read the whole thing, which we have proven because it did not take 12.5 minutes to redirect with DuckDB. It took 5. Now the MotherDuck journey starts the same. The first step is the Parquet, except now you have this R here. R stands for remote, and L stands for local. And in some example, try to say that they stand for left and right, but I can never figure out which way is left and which way is right. So no, it stands for local and remote. So we read Parquet remotely. We apply the limit remotely on MotherDuck servers. Remember, big fight to S3. And then there's a download sync that happens remotely, and a download source that happens locally. So the only thing that goes from remote to local is your 100 rows, which is negligible. Yeah, this is why I had a much better time querying S3 files directly using MotherDuck. And even you would not normally do this. You would not normally query those files directly, except as an explorer. Then imagine you would load it into a database. You would either load it into a local database, in which case, if you go to pay the 12.5 minutes tax of your time, or you would load it into a MotherDuck database, and it all happens with a single thing, regardless of what you want to do. And this is my favorite thing. The MotherDuck ecosystem, it's all the tools that have worked with us to be compatible. So you want to take your data from different sources, ship it to different destinations. You want to apply transformations. You want to visualize it. You want to run a scheduler, doing things, validate data quality, apply a graph API on top of it. You can do all of it with ecosystem. All of this is way too much for one company to handle. And it's the kind of thing where you never do a good job if you try to do all of those things. So each company specializes, they provide an excellent experience in one thing. And then people in data they pick and choose which ones of those things are relevant to their experience. All right, we got to the Q&A. Questions?
I have 2 questions. One is a joke and one's a real question. The joke question is, when will version 10 support MotherDuck?
Version 10 of
version
what?
0.10 of.
Well, MotherDuck support version 0.10 of DuckDB. That is a great point. Why should version 0.10? Because they just released 0.10.1 and they're working on 0.10.2 right now.
Um,
The non-answer is the fact that DuckDB is iterating right now towards going to their 1.0. So we work with them closely to make sure it's all compatible with MotherDuck. But if we upgrade to every minor version, it's going to create churn. It's going to create profitability potentially to our partner ecosystem, and that's enough. So it's coming soon, but I'm not doing it.
my actual question was, does MotherDuck run DuckDB's in-process memory on the server? Which is to
Yes.
say, if I ran the same query on my own EC2 instance, would I expect to get similar results as MotherDuck does, or are you doing extra magic on the MotherDuck?
You should expect to get a similar order of magnitude improvement if you run on EC2 just because of the data locality. But yes, we also do interesting thing in the backend. Our optimizer does a lot. And so if all you're doing is improve the original query that I did with getting 100 rows, you will probably get similar results. But it starts breaking down rapidly when you try to connect your local data sources to your S3 data sources to your local to your server on EC2 sources. At that point, that's the hard part.
Yeah, thanks. So your example spoke about the Meetup Dan and that being critical here. Now, my question here with DuckDB is it supported across multiple cloud services? And if so, I think I'm just trying to understand if there's going to be one cloud service that may see a lower latency compared to another cloud service.
DuckDB cares not to your mortal concerns about cloud services. It runs really close to wherever you put it. So you want to put it on edge in GCP, you can put it on edge in GCP, you can do whatever you want. If the question is about MotherDuck, right now we're only in AWS, but we will of course be multi-cloud as time goes on. And yes, your mileage is going to vary depending, of course, AWS and GCP would prefer that you do not ship data out of their own properties and into their best, most favorite competitors' properties.
Seen in your the architecture and the block, it talks about a SODA, the data quality, the SODA SQL in your diagram.
Yes, the
So
ecosystem.
what exactly the use case? Whether SODA SQL supports MotherDB as an adapter, a connector, or
Yes. MotherDuck is effectively a data warehouse that they integrate with.
so I have another question. So whether MotherDuck any plans of on the roadmap to expose the tables, whatever we take MotherDuck as a REST API to consume?
I can give you a resounding no to whether it's on the current roadmap, but given that we are a startup and the roadmap is always going to be by necessity short because you need to adapt to the changing direction, who knows in the future? Right now, there are no plans. Right now, it is gRPC all the way down. Questions, Duck funds, concerns?
So, here at Vantage, we actually run MotherDuck on, or not, we run a combination of MotherDuck and DuckDB on our servers, on our backend. Are you seeing like more of those use cases or more kind of traditional analytics use cases? And the way that we do it is actually part of our product, part of like jobs that we're processing. So just kind of curious with the ecosystem view, like what you're mainly seeing people doing with this.
We have several wildly divergent use cases that people use MotherDuck for. One of the things that will be interesting to you because you're also interested in WASM is the WASM SDK that right now is experimental, but we're improving it and it's something that you might be interested in because it's something you can run in your user browsers to analyze this data locally and still take advantage of hybrid execution when you need to fetch data remotely. But there are both kinds. So for our BI partners, for example, who their server is effectively our client. So for them, we have a restricted runtime mode, because the typical DuckDB use case is you run on your laptop where all of your environment variables are yours, your file system is yours, and you can do whatever you want. But if you are a BI tool, our Wild West client is their server, so they can't have people install extensions on their servers, download files to their servers. So we give them SaaS mode. They set an option when they start running DuckDB, and when it connects to MotherDuck, the only thing it can do is the functionality that's provided in the server. They cannot change the local environment, which again for the BI tool, that's their servers. Did I answer your question?
Yeah, I think so. I think that like, we've just been very happy with MotherDuck as like a part of the back end of our actual production service. And, I think that's maybe more unique than how people are using it today for like their analytics use cases. But yes, I think you covered it.
I think there's a lot of pull-on to get there, because you have a lot of different use cases also, even within Vantage, right? You run on the browser, you run on the servers, you have your local analyst laptops where you do analysis. So there's out of scope for this project, but we should talk more.
What's the most interesting extension that you see?
I'm really hoping somebody doesn't make no rules joke extension somewhere. I know we're not going to, because despite the duck funds, we are mature, we're a responsible company, and we will not be putting tax on your, in your databases, but I keep hoping. The weirdest use case I've seen is DuckDB has the spatial extension for dealing with spatial data, which makes total sense. What doesn't make total sense is just a cool Easter egg, and once you find it, you're going to want to use it everywhere. Spatial extension knows how to read Excel files. And nothing else does. So, you know the Swiss knife analogy for DuckDB? You can read Excel files without having to first export them into CSV or go through any of the other movements.
Very useful.
More questions, thoughts, concerns?
From your existing customer base, so when your DuckDB was just introduced, they ran it's like a local lake in place of like a snowflake, you can just run, and it just seamlessly works. And after the MotherDuck just came in, started seeing, the industry thinking about using MotherDuck as a lake itself. So any customers, any large customers are already in that in the direction.
This is pretty much the direction which we ended up moving. When I joined the company, the goal was DuckDB in the cloud. And then people kept asking for an actual data warehousing, data lake solution, and well, we're building one now, so yes.
What's coming up soon with MotherDuck that you're excited about?
GA!
Whoa.
I swear I did not want this question. Yeah, that's coming up by summer, and we are very excited about it. This can happen because DuckDB is gearing up for their 1.0, because you cannot exactly go GA while the storage format is iterating so quickly. But now that it's stabilizing, we can see GA up close, and just a little exciting thing to see something you've been working towards finally become. I mean, we have used it in production. It does not make my personal risk profile necessary, but I work for the central client, right? Nothing is going to make my personal risk profile. But it's very exciting to be GA and to be doing all the work that's needed for that. Here and the other.
Oh, because I'm curious how you view ClickHouse and like what use cases you would use ClickHouse for versus MotherDuck, or you just said.
Fairly similar, right? Fairly similar, right? We're in the same space. It's all going to be at some point a matter of personal preference. There's not going to be just one thing, that you will obviously choose. You're going to, maybe consider the ecosystem if there are other tools that you care about to integrate. But it depends, it's, something, it's up to you.
So you're committed to offer the free version for the starters and hobbyists or Apple G or any plans of this sunsetting that, the.
No, DuckDB and MotherDuck will always have funds and hobbyists. It's a way more love, like we use it. And we will always have a free tier as far as I can tell.
That's a question. How would you deal with the situation with MotherDuck if you had, let's say, 2 or multiple S3 sources located in different regions? In the case then that your 100 gigabyte pipe is not quite a 100 gigabyte pipe if they're not actually co-located, like how does that scale between like also potentially the hybrid setup where you might have multiple different pieces coming into play?
Whether you fix this in MotherDuck or you fix this with your S3 replication strategy is a question of business requirement. You could go multi-region, it's going to be more expensive from the AWS side, but it will fix this problem. And then of course, MotherDuck could be doing things on our backend, but it has not been so far a major requirement. It will someday be a major requirement. But, you know, the ecosystem, the data analytics ecosystem, it is a fair bit clustered in US. It's somewhat US centric. So the first order of business is to make the better experience for your European users and developers.